This is a video on how to use the trapezium rule to find the approximate area under a curve. The curve in this example is y equals 1 over 1 plus x squared. Not a standard curve that you need to be able to draw, but if we just use a little bit of logic, we can figure out what this is going to look like. I've gone into the table mode on the calculator, entered 1 over 1 plus x squared. Ultimately, we're going to find the area between 0 and 1, but for now, if I look at my calculator and enter a range, I'm going to go from -10 to 10 with a step of 1 and look at what y values I get for these x values. I can notice that that's a very small number, 9.9 times 10 to the -3. That's when x was -10. I'm doing this to get an idea of what this curve would look like. As the x values get bigger, these y values also get bigger. Staying positive, get bigger, it eventually reaches a y value of 1 when x is 0, which is obvious. If you sub in x is 0, you get y is 1. And then as we go beyond 0, the y values stay positive but start getting smaller. And you might notice symmetry. So when you sub in 1 or -1, you get the same y value. Whether you sub in 2 or -2, you get the same y value. We shouldn't be surprised by that because it's x squared. For example, if you square 7 or -7, you get the same answer. So this is going to be symmetrical in the y-axis. Symmetrical in the y-axis, with the y values staying positive and reaching a maximum value of 1. So it's going to look something like this, more curved than that. A bit like the normal distribution curve. Here's a nice neat version of this graph, 1 over 1 plus x squared. It's like I said, just like the normal distribution curve. It isn't the normal distribution curve, but it's similar shape. Between x is 0 and x equals 1 using the Trapezium rule with 3 strips. So I need a table for my x values. And y values. So starting at 0, going up to 1 with 3 strips. If you look at the bit I've highlighted in yellow here, the number of ordinates is always 1 more than the number of strips. So if we need 3 strips here, we're going to have 4 ordinates. That's 4 x values. The first of those is going to be 0. The last, or the fourth, is going to be 1. So we need 2 more in between. Also, if you just think about this, we're splitting this interval into 3 strips. That interval has a length of 1. So each strip will have a length of 1/3. So our ordinates are going to be 0, 1/3, 2/3, and 1. Just picture that from x is 0 up to x is 1, breaking it apart into 3 strips. So here's strip 1, strip 2, strip 3. The width of each strip has to be 1/3. To get these y values, I'm going to use the table mode in the calculator. So there's 1 over 1 plus x squared. Start my range at 0, end it at 1 with a step of 1/3. When I typed this in, I didn't type 0.3333. I typed 1. You could use the divide button or the fraction button. So 1/3. It turns it into that, but we must enter it as 1/3. So here we go. So when x is 0, we get a y value of 1. We could have done that without the calculator. When x is 1/3, then y is 0.9 or 9/10. And when x is 2/3, y is, it gives me this decimal. We're going to see if we can get that as an exact fraction. Because when I need this number later, I don't want to use a rounded value. So there we have 9/13. That keeps it nice and exact. And when x is 1, y is half. So there's our values. We now go back to the trapezium rule, and here it is. Basically, it's a half times h, where h is the width of each strip. That's what we worked out at the beginning. The width width of each strip is 1/3. Just going to write that down. So h is 1/3. We found that earlier just by thinking about it. There is a formula for it, but if you're going to use the formula, you need to know what n represents. So here n represents the number of strips. You'd have to remember that if you're going to use the formula. So it's half times h, and then a bracket that opens and doesn't close until the very end. So half h times everything. y0 plus yn, that means the first y ordinate plus the final y ordinate, and then plus 2 lots of all the other ones. So this area will approximately be half times h is 1/3, and then some brackets that open and do not close until the very end. First we have the first y value and the final y value, plus 2 lots of all the others. So 9/10 plus 9/13, and then the bracket closes right at the end. Enter all this into your calculator carefully. So there we go, I've entered it into the calculator, and I get 203 over 260. That is only an approximation for the area. If you want to see what that is as a decimal, it's about 0.781 to 3 sig fig. Now, a common mistake with the trapezium rule is to forget that these brackets exist. Some people totally forget about them and enter that in the calculator. Make sure you don't forget. Another common mistake is, instead of using the y values here, is to use the x values. Make sure you don't make that mistake. This concludes this example.